All right, so in this section, we're going to be talking about light and color. Light and color are pretty much inseparable, which is why we're going to cover them in this same section. So before we really start getting into painting light and color, I think it helps if we have a fundamental understanding of how light and color reacts and acts in the real world. So you can see here we have a sphere, just a basic black and white painting of a sphere, a little bit of white light, and we're going to go over the different parts of an object when it's being lit. So first, I'm going to go ahead and get a white color here so we can sort of write these in here. So we have, oops, let's bring my brush over. Here we have what is called our base color or value. This is sort of what, in a sort of like a vacuum, if there was no light and no shadows, what would we have the base of our object be? That's what this color is right here, this sort of neutral gray, okay? Then, as we move closer to the area that's not being hit by the light, we have the shadow side. This dark band that kind of comes along the backside here, that's what is called our core shadow. That's where our shadow gets the darkest. This side down here, you can see it gets a little bit lighter. That's because light is coming down and bouncing off the ground and bouncing back up to hit the sphere. This is called our reflected light. Over here where it gets really bright, this is going to be the lit side. And then this little tiny spot right here is what we call the highlight. And then last but not least, we have this over here, which is our cast shadow, which is from the ball itself casting a shadow on the ground. Now, everything you paint is probably going to have every single one of these. Depending on what the subject is or what the lighting is like, it might not. For example, if you're painting in outer space where there's no other objects besides what's being lit, there probably won't be any reflected light. Or maybe you're painting a subject that is really matte or rough, it probably won't have a highlight. But for the most part, a general rule of thumb is that everything you paint is going to have each of these features unless otherwise stated or worked into the equation of whatever it is you're painting. So let's talk a little bit about how light works. So I'm going to turn this layer off. We're going to turn this on. So these represent light rays. You want to think about light as individual particles that are coming down from the light source. So for example, if we use the sun is beaming these light particles down to objects on Earth. And when those light particles bounce off the objects, the particles that bounce off and then go into our eyes is what we perceive as light. So, for example, you can see here in this, the light rays come down, they bounce off, and they're going to bounce around the scene, and eventually some of those light rays will make it into our eye, and we'll be able to perceive this image. The areas that have highlights are where the light rays are bouncing more directly into our eye, and the farther away it gets, less light is bouncing into our eye, which is why on the shadow side, it appears darker. Okay, now you can see when we have a light source, if our light source is coming from up here on the top left and the light is coming down, anything that is getting blocked by the ball is going to have a hard time getting any sort of light. So which is why we have what is called this cast shadow. The light rays are coming down, and if we turn on this other light, you can see these ones come down, they hit the ball, and then they bounce off. These ones don't hit the ball, they keep going, and they hit the ground instead, which is why the ground is lit up, but the area behind the ball is in shadow. And then on top of that, those light rays are going to continue to bounce around. Every time a light particle bounces off something, it loses about 90% of its energy for each bounce. So very quickly, it's going to become much dimmer, but it will still bounce around a little bit, which is why we get this reflected light on the bottom side of the ball. Instead of it just being pitch black in the shadow, like it might be in outer space where there's no reflected light because there's nothing for it to bounce off to, it instead creates this little bit of light source. But even though it's the exact same light as what's creating our highlight, because it's bouncing off the ground and then bouncing back, it's lost so much of its energy that's going to be a lot more subtle and not very visible as well. Same with the cast shadow here. It gets very light as it gets towards the edge of the cast shadow because more light is able to start bouncing around and lighting that area up. But the closer it gets to the actual ball, the harder it is for light to get in there because it's so close to the ground. Okay, so that's how the basics of light work. Now let's talk about color. So we'll go ahead and turn this off. We can turn all these layers off. And we will come up here. I'm gonna make a new layer so that we can take some more notes on this. Here we have a nice big bright red ball and sort of a blue lit room. So we have a lot of the same features as our black and white version. We have the core shadow, we have the highlights, the lit side, the shadow side, reflected light, cast shadow, and I think that this covers everything. So there are a few differences though that you want to take into account when you're using color. So the shadow side here is being lit by the ambient light source of the room. The ambient light source means what's kind of just the light floating around in the area. So you have a direct light source, which might be like a light bulb, a flashlight, or the sun, where it's very harsh, it's very directional. And then the ambient light source would be something like the sky, or just sort of the lighting in a room. If you were to turn the light off in the daytime, there's still sort of light bouncing around. That's because little light particles are coming from under the door, from the window, all these different areas, but they bounce around so much the light becomes very diffuse, and so your shadows are very soft, they're not very harsh, right? So whatever that color of your ambient light source is, that's probably what color your reflected light is going to be, as well as whatever the surface reflecting the light is in addition to that. So the surface for this is kind of a blue ground, therefore the shadow side where the reflected light hits on this red sphere is a little bit more blue as well. Okay, the light source here is a yellow light, and so it starts to make the ball look a little bit more orange. And then the last thing you want to take into account when you're working with color is that right along your core shadow, where your light side starts to turn into shadow, you're going to get what's called a saturation band. And that's where the color gets a lot more saturated, right there where light meets shadow. Once again, these are things that are going to depend a little bit on the subject you're drawing, but for the most part, this is something that you can use to rely on. And you can even observe a saturation band just by going outside and looking at where the sun is casting a shadow on something, whether it's, casting a shadow from a house or a car or garbage can, whatever. If you look really closely where the light meets the shadow, you'll see that there's this little band of color of usually orange or red where it gets really saturated right along that transition. That's something that I found that adding that to your work adds a whole nother dimension of life and realism to it as well. So let's talk about exactly how light and color works scientifically. So we have these here, and these each represent different particles of light. So light particles, they kind of come on a spectrum from red to violet. And as these kind of come down and bounce off objects, depending on the makeup of the object, it'll determine which light particles get absorbed and which ones bounce off and make it into our eyes. So you could see, because this ball is red, what's happening is that all these different colors of light particles are coming down. The green ones, the blue ones, the purple ones, the red ones, the yellow ones and the orange ones, for the most part, are getting absorbed. And the red ones are what is bouncing off of the object and making it into our eye, making us perceive the object as red. So you can see that based off of the color of the light, it'll determine what ones get bounced off, as well as the color shadows. You can see here in the back, blue light is coming off, but because our object is a red object, it's not just coming straight blue, it's kind of mixing between blue and red and giving us a little bit of a purple. Same with our light source being yellow, the yellow light is coming, bouncing off, but it's mixing with the red, giving us a little bit of an orange that bounces off. So hopefully that gives you a basic understanding of how light works. This isn't something that you need to draw out every time you do a painting. You don't need to draw a bunch of light rays or anything like that. This is just to help illustrate the idea and get it in your head so you can kind of start thinking about it from a more strategic position and trying to kind of help you understand how light is working and think of it as little particles bouncing around in a scene in order to help you light it. That way you can start taking steps to better and more realistic paintings. So that's it for this lecture. I will see you guys in the next one.